right. Good morning, everybody. Today is Friday. Yeah, it's Friday, November 17th, 2017. And this is Before the First Cup with Jules here on UCY.TV. Happy Friday, everyone. It is an overcast and cloudy, 32 degrees, very damp here in upstate New York. So where do we leave off yesterday? We titled the show AI, Robots, Swarms, Robo-bees, nanobots, and digital pills. We looked at a lot of crazy technologies that are coming down the pipe that are going to be influencing our future. Well, today we're going to stick in some of the same technologies, looking at swarms and large groups of things working together. And today we're going to look at cloud intelligence, cloud super intelligence, and some of the things that are going on with a computer science guy named Ben Goertzel. We haven't really talked much about Ben Goertzel. I always thought of him as a stoner academic, but he's coming out of the wings. He has all kinds of projects going on. He wants to be able to create a benevolent super artificial intelligence. And he's started this group called Singularity Net that is going to be a cloud store for artificial intelligence that is open sourced. And they're using blockchain to build all kinds of things. So I want you to get familiar with him. We are going to be talking to Drew Lamb at some point next week in regards to Ben Goertzel and him being a part of Hanson Robotics, where Sophia came from. There's some interesting things going on. All right, here we go. Everyone have a great weekend. I'll catch up to you on Monday.
Singularity, as I understand it, it's a point in time where the rate of advance of science and technology gets so fast, the human mind perceives it as infinite. Right now, already, we get new computers and new mobile phones faster than I can figure out how to use them. I don't know everything my phone can do now, and I'm not going to figure it out by the time I get the next one. But imagine if a new technology with amazing new implications came about every 5 seconds or so. That's a singularity. But the singularity is not just a matter of technology. It's better, perhaps, to think of the singularity in terms of human experience. Right now, due to the way our brains are built, we have a few states of consciousness that follow us around every day. There's the ordinary waking state of consciousness. There's various kinds of sleep. There's a flow state of consciousness that we get into when we're really into the work we're doing, or playing music and we're really into it. There's various enlightened states you can get into by meditating a really long time. The spectrum of states of consciousness that human beings can enter into, it's a tiny little fragment of all the possible ways of experience. When the singularity comes, it's going to bring us a wild variety of states of consciousness, a wild variety of ways of thinking and feeling and experiencing the world that we can't even imagine now. The singularity will be enabled by technology, but fundamentally it's not just about technology. It's about how you feel in your own mind. It's about how you feel in your body. It's about how you relate to the world and to other people. It's going to be a radical change in what it feels like to be a person, to be a mind. Why do I believe a singularity is coming? The singularity has been coming for quite a long time. Not that long ago, our ancestors were running around in the African savannah, living not that differently from other animals. Then we developed language, we developed tools, we developed machinery, we developed mathematics, we developed science. This has been a very rapid rise for humanity, from our beginnings in the African savannah to where we are today. The singularity is just the next small step, adding on to all the amazing things humanity has already achieved. As Ray Kurzweil has pointed out, for the last few decades, we've been seeing exponential advancement in a number of technologies that are directly relevant to the singularity. The exponential advance of computer hardware is obvious to everyone. The supercomputers of decades ago are vastly less powerful than my cell phone, let alone the server farms I use for AI development. The exponential advance of brain scanning has been equally amazing. Now we can track which parts of the brain are active when we have a certain kind of thought. We can look at the activity in a human brain when a person looks at a picture, and we can reconstruct that picture from what's happening inside their brains. Nothing remotely like that was possible a few decades ago. We now have quantum computers, simple hardware devices that use the weird quantum uncertainty voodoo of the microworld to carry out computing fundamentally faster than regular computers could do. We now have humanoid robots like the Now and the Hanson Robo-kind, little guys 3 feet tall you can buy for 15,000 US that walk around your lab and talk to you. This was unimaginable a decade ago, let alone 50 years ago. We're seeing exponentially fast advancement in a variety of different technologies. Genetics, all of a sudden, is an information science. When I studied biology in high school, it was pretty boring. Genetics has become an information science. In the last decade and a half, we've sequenced the human genome. We've sequenced the genomes of fruit flies, mice, and all manner of different organisms. We can apply AI technology to the genomes of all these animals. We can connect genomics with systems biology simulations, computer simulations of the complex systems inside a human's or an animal's body. Using the combination of advanced biotechnology with AI, we can begin to understand the complex mechanisms that make us live and breathe and that make us get old and die. So there's a host of intersecting technologies which are advancing exponentially for the last few decades, building on the much longer term exponential advance that brought us out of the African savannah to where we are today. Given all this, it's not hard to see why Ray Kurzweil projects a singularity sometime in the middle of this century, and I tend to agree. We don't need every technology to advance exponentially to have a singularity. This sweatshirt I'm wearing, it's not all that different from the sweater my grandfather wore. The chopsticks I'll eat dinner with tonight, they're pretty much the same as the chopsticks that were used in China 5,000 years ago. We don't need every technology to advance exponentially to get to a singularity. We need a few key technologies. Specifically, we need those technologies that form the underpinnings of artificial general intelligence, because that's really the crux of the singularity. Once you have a mind that's fundamentally smarter than the human mind, twice as smart as a human, 3 times, 5 times as smart as a human, at that point we're into a different domain of reality. We're into a different phase of history. These superhuman minds are going to go as far beyond human beings as human beings have gone beyond chimpanzees, lemurs, and our other precursors. AGI, artificial general intelligence, refers to an engineered system, a machine or a computer program, that can learn, reason, understand, generalize with the same breadth of scope as a human mind, and ultimately far beyond what the human mind can do. Most of the AI programs written so far are what we'd call narrow AI. They may be very, very smart, but they're smart in a very particular domain. You have a program like Deep Blue that plays chess better than any human being, but it only plays chess. It can't play checkers. It can't play Go. It can't even play Fischer random chess or any of the other variations of the standard chess rules. The U.S. military has some fabulously complicated AI planning and scheduling systems that work out all the logistics of complex military operations. But if you take these planning and scheduling systems and try to get them to organize a conference or run a government, they can't do that. They're tuned specifically for military logistics. In my own bioinformatics company, BioMind, we've used narrow AI to analyze genomics data. And we've discovered some really important things about Parkinson's disease, Alzheimer's disease, and longevity. But these narrow AI bioinformatics systems require a human expert to operate them. And if you feed them a new kind of data they've never seen before, they require a human to pre-process the data, to put it in the right form they can understand. Narrow AI systems can be incredibly useful technology, but they're not autonomous systems. They're not autonomous, self-understanding agents that confront the world on their own terms, understand their own relation to the world, and figure out how to achieve their own goals in the context of an uncertain, ever-shifting, ever-evolving environment. People aren't that good at any one particular thing. What we are good at doing is figuring out what to do in uncertain situations. This is the crux of what makes AGI different than narrow AI. Humans aren't absolutely general intelligences. We are limited in some ways. Something like a third of the brain is devoted to vision processing. Obviously, we're not much good at doing mathematics. We struggle with algebraic calculations. This software program like Mathematica or MATLAB could do effortlessly and instantaneously. We're not equally good at everything, and there are some things that are just so complex a human brain couldn't possibly grapple with them within a human lifetime. But even so, we do possess a capability to generalize, to transfer knowledge from one domain to another that current AI programs don't have. Some AI theorists, like Marcus Hutter and Jürgen Schmidhuber, have theorized about infinitely general intelligence, an AI system that could solve any possible problem. This is really interesting mathematics. But when you come down to it, an infinitely general intelligence is only possible with infinitely much computer processing power, and that's not the situation we have in the real world. The human mind is an adaptation to the fixed computing resources of the human brain. Any AGI system we build is going to be an adaptation to the fixed amount of computing resources that it has. So we're not going to build a completely general AGI system that can solve all possible problems immediately. But we can build something with the same and ultimately greater generalization capability than the human mind. And once we have that, it's literally impossible for human beings to figure out what comes next. There's a certain fundamental, irreducible uncertainty to the singularity. Just as a cockroach or a dog can't predict what product Apple is going to release next year, or what molecular nanotechnology is going to enable, or even what's going to happen next in a soap opera. Similarly, the human mind is going to be fundamentally unable to predict what happens in a world dominated by superhuman general intelligences. This doesn't mean a Terminator scenario is inevitable. It does mean we're not going to have a predictable, cut and dried future where we can see what's coming every step of the way. Here in China, there's been a fairly stable situation for thousands of years. Emperors have come and gone, but the basic Chinese culture has remained the same. The library in Beijing contains records of the Chinese Empire going back 5,000 years or so. The future's not going to be like that. The records in Beijing are not going to be as relevant anymore once superhuman AIs are the dominant factor in the world. Some of my friends in the futurist community believe a negative outcome is likely. They think once we have superhuman AIs, these AIs are more than likely to wipe us all out, either out of malice or just out of indifference. After all, when we humans erect a new building, how much do we care if we wipe out some ants or some bacteria along the way? But I'm much more optimistic. Superhuman AIs are not going to be random minds pulled out of the nothing. And they're not going to be minds that evolve in a fierce need. And they're not going to be minds that evolve in the context of a fierce evolutionary battle for survival. We're engineering these minds. We're building the artificial minds that are going to supersede traditional human intelligence. We can architect these minds with rational goal structures. We can architect these minds with ethical goal structures. We can set these minds off on a positive course. That doesn't mean we know with any certainty where they're going to go, but it does mean we can have a rational expectation that something very positive might well happen. Look at the applications to medicine. Look at the applications to longevity. Right now we take for granted that all of us are going to get old and die. I turned 45 years old yesterday. If nothing radical happens, that's more than half my expected lifespan. I don't fear death tremendously. If it turns out that I die, that's okay. I've enjoyed my life. I've done a lot of what I wanted to. On the other hand, all in all, I would much rather not die today, for example. And I would much rather not die 45 years from now or 10,000 years from now. Life is good. I'd rather life keeps on going. And death is not inevitable. We're raised to believe that once you're born, you're going to live a while and then you're going to die. Because that's the way evolution has worked it out for us. But that's not the way it has to be. The body can be thought of as a complex molecular machine. A sufficiently intelligent AI could figure out how to repair this machine to avoid the problem of involuntary death via aging or disease. The mind, the conscious experience that we have, ultimately, it comes out of a certain organization of activity in our brain. It's a pattern of activity. This pattern of activity that makes up the human mind could be ported to a different substrate. A sufficiently intelligent AI could copy the mind out of a human brain into a different sort of physical system, which is much more robust. One day we're going to look back on this era when we could not even make a backup copy of ourselves. If lightning were to strike me in the head, I'd probably be gone. After the Singularity, all you'd have to do is reboot me from my most recent backup copy, and I keep on going. Imagine the ramifications this will have for the way we think about ourselves, for the way we think about our lives. One of the problems we've seen as technology has advanced is that we human beings have caused more and more damage to our natural environment. Ironically enough, I think really advanced technology like AGI and molecular nanotech can reverse this trend, can actually make it easier for people to coexist with their environments and help us create new natural environments flourishing in amazing ways that nature never knew before. Here in Hong Kong, it's a little known fact, but 80% of Hong Kong is undeveloped wild natural areas, just tree-covered mountains. The populated areas of Hong Kong are quite compressed and crowded, and part of the reason for that is that 80% of Hong Kong is not zoned for development. It's just left wild for the animals and plants. I see no reason why we can't keep it that way. The primitive technologies we have now that are causing so much damage to the surface of the earth will be obsoleted come the singularity. Digging up fossil fuels from under the ground is going to be unnecessary once we can do nuclear fusion, femto technology, harvesting energy from the center of the sun. The phase of development where technology harms the earth, it's probably quite temporary. We're going to see a reversal of that trend where technology actually helps both humans and nature to flourish, live together in harmony. There's a lot of cool things that could happen, actually. I mean, you could bring back the Neanderthals, too, right? Advanced technology will let us preserve the beauty of nature much better than we can do now. And it can also enable some more interesting things. We could bring back extinct animals from their DNA. We could allow the flourishing of new ecosystems, new kinds of plants and animals that nature didn't happen to come up with. We don't have to think of the future as a kind of sterile environment like a computer lab where there's just a bunch of big metal machines sitting around whirring and humming. I mean, the post-singularity future could be way more natural, way more wild and alive than the world we're living in today. We launched OpenCog as an open source project in 2008, but it was actually a continuation of a project we'd started in 2001 as a proprietary AI system. The proprietary system was called the Novamente Cognition Engine. We launched it inside my startup company, Novamente LLC. But by the time 2008 rolled around, it became clear to us we weren't making the kind of progress that we really wanted. We were doing okay, but we didn't see ourselves getting to a human-level thinking machine anytime soon. Not at that rate. So we figured, what the heck? Open source the code, see what additional participation we could get from around the world. When you launch an open source project, you can get contributions from all over the place, from universities, companies, government agencies, private individuals who just have spare time. They want to contribute to your project. We didn't know exactly what to expect. One of the big surprises once we open sourced OpenCog was the involvement that we got from Asian universities. I started a collaboration with Xiamen University in China, a small city on an island in Fujian province, just across the water from Taiwan. Some students in Xiamen University connected OpenCog to a humanoid robot, a little white humanoid robot bought from France, the Now robot. OpenCog controlled the little robot, walking around in the lab, holding simple conversations, planning its actions, recognizing objects. This sort of collaboration would not have been possible if we'd kept OpenCog as the proprietary Novamente Cognition Engine. The next Asian collaboration was OpenCog Hong Kong, a collaboration between my company Novamente and Hong Kong Polytechnic University. This was a Hong Kong government grant, a corporate matching grant where my company put in part of the money, the Hong Kong government put in the rest. This is funding 6 AI programmers to work on using OpenCog to control intelligent video game characters. And we're doing that from 2 purposes. First of all, to create intelligent game characters that can really be used in video games. We want to commercialize the technology so as to make money, and also so as to get millions of video game players around the world to collaborate on teaching our AI. as part of their game playing experience. And the second goal being to work toward building a thinking machine. Because once you think about it, you see that using an AI to control a video game character is confronting nearly all the hard problems of AGI. What do you have in a video game world? You have perception, you have action, you have abstract cognition, you have social interaction, you have emotion, you have the need for planning across various different scenes and situations, spatio-temporal inference. Pretty much everything we need to do to be a human is contained in some simplified form in a video game world. I'm not sure that a video game world is enough to get us to human level intelligence. My guess is that we're going to need to use OpenCog to control robots, exploring natural environments, perceiving the rich natural world, and interacting with the world with the same kind of richness that the human body can. But even if we need to go to robots eventually, we can prototype nearly every aspect of our AGI architecture in the video game world. Doing AGI development in China has been a real lot of fun. There's a really high level of energy here. It's unlike anything I've seen in the US since the late 90s with the .com era. I founded my first AI company, WebMind, in New York City in the late 1990s. We were on Broad Street near Wall Street in a scene that was called Silicon Alley back then. Silicon Alley was not as well known as Silicon Valley in California, but it was every bit as exciting, with more of an emphasis on media and on hard technology rather than website stuff. Back then in the US, in the .com era, there was a real feeling of enthusiasm and excitement. You had young people coming together to form new companies, building new technologies with a real deep confidence, with a really deep confidence they're going to change the world. We didn't know exactly how we were going to change the world. We knew the internet was going to be a huge thing. We knew the internet would be tremendous. We knew that some kind of internet technology was going to dominate the world during the next decades, but we didn't know exactly what kind of technology it was going to be. So there was a feeling of great open-mindedness. Investors were funding all sorts of internet projects. People were thinking in every possible direction about what the internet might turn into. Not everyone made money then. As it turned out, WebMind, my first startup, didn't do that well. But we developed a lot of cool ideas, a lot of great technologies, and on the whole, the thinking, the science, the technology built during the .com boom laid the ground for what the internet is today. The same enthusiasm I saw in America during the .com boom, I see right now in Hong Kong, in Shanghai, in Beijing. I see young people coming together to build new technologies with a belief in their hearts it's going to change the world. And I see a great optimism about the future. America still has an awful lot going for it. Probably 75% of the top universities in the world are in the USA. You've got Apple, Google, Microsoft, IBM, a lot of great companies in America doing a lot of great things. But you don't have the same kind of feeling, the same kind of attitude of open, unbounded growth. Like each year, things are getting better and better. Like each year, more and more new things are being invented, being rolled out in the world. You had that feeling in the US in the .com boom, and you have that feeling here in China right now. I have to say Hong Kong is probably the most alive and vibrant place I've ever worked. It's really a non-stop pace of life and pace of working. Historically, the United States has been the site of almost all the AI development to happen in the world. All the major AI paradigms have really come to fruition in America. But all that history of AI in America is both a strength and a weakness. It's a strength because there's a richness of knowledge about AI and of the practical application of AI technologies that you don't find anywhere else in the world. It's a weakness because the AI ideas that have served America so well in the past probably aren't good enough to lead us all the way to human-level AI. Yet the AI funding agencies in the U.S., the major companies using AI in the U.S., are kind of reluctant to shift from the AI ideas that have served them reasonably well in the past. They're kind of reluctant to invest in wacky new AI concepts like OpenCog. On the other hand, in China or Korea or other Asian countries, you don't have that same kind of history. You have a lot more openness to wild new ways of thinking about AI. The Chinese government and the major Chinese corporations, they know they need artificial intelligence. They want service robots. They want AIs to help coordinate all their infrastructure systems. They want AIs to help educate their population better. They want AIs for dozens of things across the board. If you look at the latest science and technology plan of the Ministry of Science in Beijing, AI is there all over the place, far more than you see it in the planning documents of American or European governments. So the Chinese government knows they want AI, but they don't know how to do it. And they don't think they know how to do it. It's been easier for me, with my somewhat novel and eccentric approach to AI, to find interest in funding here in China than in America. The Chinese recognize that OpenCog is a bit out there, that it's a different way of thinking about the problem, but they like that. They're not wedded to any good old-fashioned approaches to the AI problem. I also think the holistic aspect of OpenCog appeals somewhat to the Asian mindset. There's a lot of people in the West who think about AI in terms of one silver bullet, one magic algorithm that's going to solve everything. The Chinese are more used to thinking about complex integrated systems, about holistic systems where all the parts contribute, putting in their own unique aspect, and the behavior emerges from the whole. OpenCog is very much like that. We have many different ingredients. You have PLN over here, our logical inference system. Moses over here, our procedure learning system. You have episodic memory, you have perception, you have action. All these different parts come together, forming a synergetic whole, which leads to intelligence. This kind of focus on synergy and emergence and complementarity is very natural to the Asian mindset. We've also seen some cases where the Asian culture, the Asian mentality of the developers working on the system has had some impact on how the development goes. One of the members of our Hong Kong AGI team, Shai Jianhua, he was given the task of programming the emotion and motivation system of OpenCog. One of the first things he said when he saw the design I wrote was, wait a minute, you haven't given social adjustment and social harmony as one of the top level goals of your system. We'd provided the AI initially with a number of simple top level goals like feeding itself inside the virtual world, learning new things and experiencing novelty, pleasing its human teachers. But we hadn't thought to supply a top-level goal of social harmony and getting along well with others and pleasing its peers. So Jianhua, with his Chinese mindset, looked at our motivational system and said, wait a minute, you've given the social aspect short shrift. So he implemented the initial motivational hierarchy of the OpenCog system in a way that reflected his own Asian values, along with the Western thinking that had gone into our original design. Right now, OpenCog is fairly simple in terms of what it can do. So the social and emotional aspect isn't all that sophisticated. But as we go further down the road toward creating more and more advanced AGI, it may well be that the Asian setting has a significant impact, because the people interacting with the system as it grows up aren't just going to be Americans. They're going to be a mixture of Westerners and Chinese. In terms of life, the universe, and everything, first of all, to frame the discussion, I wrote a brief book maybe 7 years ago called The Cosmist Manifesto, the name of which was inspired by Tsiolkovsky, Fedorov, and the Russian cosmists. And a few of the premises there are listed on this slide. I mean, I believe that in the next decades and centuries, humans will merge with technology in various ways. We'll develop sentient AI and mind uploading. We will leave Earth and roam around the universe. We'll create virtual and synthetic realities. We'll re-engineer space-time. Many of the things that religions have promised, analogs of those, will come about through technology, although probably not exactly what religions have promised, such as a heaven could exist in a virtual reality. Reincarnation of a form could exist if you manage to reconstruct someone from traces they've left behind in the world. I think the domain of material scarcity that we now live in is going to be gone, and our great grandchildren will look back and be baffled that people had to work for a living. Like they'll be you had to do stuff you don't like to do all day every day in order to get some tokens you exchange for like food and water and shelter. This will seem bizarre to them in the way that slavery or cannibalism seem strange to us now. I mean, not to say that everyone will be able to get infinite resources. I mean, if you want to spin up a new solar system to play with, there will be competition for resources on some level, most likely, but the era where we have to work and struggle and compete for resources that feel like basic needs relative to our minds and bodies, I think that's going to go away relatively soon. And I think the ethical systems that are prevalent on Earth will change a great deal and become more flexible, which has already been happening in the world as we've moved toward more and more advanced civilizations. And this is not just about technology. I mean, amazing new states of experience and social interaction will come out of all this. I mean, what it feels like to be alive and to experience each moment will become quite different. I mean, in the same way that our experience is radically different than that of, say, a dog or a cockroach or of a primitive tribes person who didn't know written language, mathematics, science, movies, and so forth. So I think a lot of big things are going to change, and above all, this list will probably seem astoundingly archaic in 100 years once our intelligences are 1 billion times what they are now. I mean, just as, if I asked my dog, what amazing, exciting future would you envision? To be like all the steak I can eat, and like I can run around in fields and like mate all the time, and they're not going to say, well, I can download all the movies I want, or I can discover unified physics or fly to other planets. So all these amazing things we envision now, these are probably just scratching the surface. And there's a lot of technologies that will be involved in creating this type of future. I mean, there's nanotechnology, synthetic biology, physics, if you're doing space-time engineering, and we still don't have a unified physics. I mean, for virtual reality, there's all sorts of issues with interfacing the brain to computer systems that will generate synthetic realities to feed into us. There's brain-computer interfacing, body modification to let us fly through the air. But among all these technologies, I do think that AI, and specifically artificial general intelligence, is likely to be the most impactful one. And I mean, this is because, as I.J. Good said in the 1960s, the first truly intelligent machine will be the last invention humanity needs to make. I mean, once you have an AGI, that AGI can proceed and invent nanotechnology, synthetic biology, space-time re-engineering, and so forth. And none of these other advanced technologies on the horizon have the same potential to take over the invention process and bring it way beyond where humans have brought it. So my approach to AGI, if you're interested, you can find on Amazon my book, The AGI Revolution, which is reasonably non-technical for a general audience. So if you're a computer scientist, you could look at the book Engineering General Intelligence, which is sort of the high level. It's 900 pages, but it's sort of the high level abstract of the OpenCog AGI system that a group of us are building, which is a big and complex undertaking. Now the guts of the OpenCog would-be AGI mind are hard to visualize. I mean, the knowledge base inside the AI is a big graph. It's a weighted labeled hypergraph, nodes and links of an abstract sort in the computer's RAM, and we have a bunch of learning and reasoning algorithms acting on these nodes and links. So there's a probabilistic logic engine and evolutionary learning framework. There's some deep neural nets for dealing with visual and auditory perception. There's an activation spreading system that spreads around attention to different things in the network. And there's a lot of subtlety here. We've solved a lot of problems. We have some more problems to solve. One of the things we're applying this system to, not the only one, but the one that's easiest to show off, is controlling these humanoid robots that we're making in Hanson Robotics in Hong Kong, where I've been based for the last 6 years. So I'm not going to run through all these robot videos I have here in great length, but just give you a little snippet. This is an old human-scale Einstein robot from like 10 years ago. Actually, we have a new one that we're going to showcase at the Consumer Electronics Show in January. This is the Sophia robot, which is our most sophisticated one, which looks really uncommonly like a human. And I think this robot has the most realistic facial expressions of any robot in the world. We had a sing at a music festival in Hong Kong earlier this year, which was kind of cool. What was cool is people walked by and didn't know it was a robot most of the time. Then they'd see the plastic hands, which we kept kind of crappy on purpose, and then they were, whoa, what's that? Is it a person with plastic hands? No, it's a robot, right? So, yeah, we have male robots. The sound here isn't good, so I won't run through it too much, but this video you can find on YouTube if you look up OpenCog Hanson Robots Reasoning. It was a demo where Man Hin, one of our AI developers, he's somewhere in this room, I think, right, was running the robot through some basic logical reasoning exercises. And see, what else do we have here? Oh, we get the robots to debate each other sometimes. Do you ever play cookie for work? That's kind of funny. In theory, they can learn from each other. Usually, they just get each other more and more and more confused the longer that they talk to each other. But
how do I know you were telling the truth? By introspection. Possibilities are endless.
We had a great debate among these two robots at the RISE conference in Hong Kong a few months ago, which you could find on Facebook videos. I think if you look at Hanson Robots RISE Hong Kong, and we're going to do that again at the Web Summit in September. And I mean, humanoid robotics is not AGI; it's its own discipline. There's a lot of subtlety to the material science and the control theory and so forth. From an AGI point of view, that gives you two things. I mean, first of all, it gives you a really cool user interface because everyone loves to see these beautiful robots, and they get people excited in a way that abstract data structures and algorithms aren't going to do. And we do a lot of other things with OpenCog. We analyze genomics data to help biologists understand aging and disease, and we're experimenting with mathematical theorem proving. These things are equally useful for advancing us toward AGI, but they don't reach out to average people as much as the humanoid robots, because everyone can, when the robot smiles, looks them in the eye, and understands what they're saying even a little bit, they're like, wow, there's some intelligence there. So there's that aspect of the robots. They're great for just reaching out to people. But I also think that embodiment in something that can see, hear, touch, and experience the human-like world and interact in the human-like world, that has a big advantage in terms of getting human-like intelligence into the AGI. Because there's a lot of common sense knowledge that we all share as part of our culture, and the easiest way for an AI to absorb that is to be able to enter into our world and absorb it from us directly in interaction with us. So, I mean, our plan is to use these humanoid robots to advance toward more and more capable AI systems. First getting a humanoid robot that can really hold a conversation with you with genuine understanding of what you're saying in the context of what's going on around it. And we're getting there. We're doing a little bit of that, but we're not really there yet. I mean, you'd like the robot to be here to understand it's in a conference room. All these people are sitting in chairs, and they're going to get up and stand and go away. Understand that people can talk to each other, and understand if someone falls asleep, that if you poke them, they'll wake up. Just get basic understanding of the situation that it's in and be able to discuss based on that, which is what everyone expects of robots from science fiction. We may be a few years away from getting there. I think that we know how to do it, but there's certainly a lot of work to get there. Once you're there, then you're in a very interesting regime, because then you have something that you can teach. Like you can teach it math on the whiteboard, and when you write 2 + 2 = 4, you can show it 2 things here, and count 1, 2, 3, 4 things. I mean, you can connect abstract knowledge with embodied observations and experiences. Then you can start to teach the robot like a kid. And once you get to that point, you can almost say building a full-scale human-level AGI is more of a management problem, because you know you're going to be able to do it by improving the algorithms and teaching it more and more, and you're going to be able to get as many resources as you want to achieve it. And furthermore, I suspect that once you get to a human-level AGI, getting to a superhuman AGI is going to be quite rapid. I mean, not like 5 minutes. It's going to rewrite its code and then rewrite the universe 5 minutes later. But I think it will be years and not decades from a human-level AI to a significantly superhuman AI. Once you've taught that AGI to program computers and to analyze algorithms and to be a computer scientist, I mean, then it can advance quite rapidly, because it can make many, many, many copies of itself, which can learn from each other, and it can apply its knowledge to modifying its own source code. And as it modifies its own source code based on its computer science discoveries, it can make itself smarter and smarter and smarter and smarter. And this is the recursive self-improvement that I.J. Good was writing about in the 60s, and Ray Kurzweil has discussed in his book, The Singularity is Near. Now that really only kicks in my view, once you have an AGI that has the intelligence of a human-level adult who's able to understand computer science, algorithms, math, programming, engineering, and so forth. So there's like zero probability, or very, very close, that some simple AI program is suddenly going to like blast out of control and become superhuman. On the other hand, once you have something that's like a top-level computer scientist, which is a program in a computer that can copy itself to many hard drives and hack its own code, that then getting astoundingly fast progress seems quite possible. There's a lot of unanswered questions here. I mean, people always ask about consciousness and subjective experience, and I think we don't have a solid answer to that. My strong intuition is that a digital computer program that has the same basic behaviors as a human being and the same practical understanding as a human being is going to have consciousness in the same sense that a human being does. But I'm open to being refuted on that if empirical studies come out differently. I mean, an experiment I thought of as if I connect my brain with a wire or some analog to some other human's brain, and I feel their consciousness there on the fringe of mine, then I connect my brain to the robot's brain, and I don't feel their consciousness. I feel just like if I connected my brain to a brick or something. I mean, eventually this sort of second-person experience might convince me this robot is just faking it and doesn't have any actual experience. So I mean, there's a lot of ways that we're not thinking of now that could be used to explore consciousness. I think AGIs can be a very powerful tool for this. Another interesting aspect is what my friends at the Global Brain Institute in Brussels call the global brain. So, I mean, you could take a lot of different AIs around the world, network them together into one sort of AGI Borg mind, but then once we all have the chip in our head instead of in our pockets, which is almost inevitable once brain-computer interfacing advances a bit, I mean, then the chips in our head, which are giving us in-brain access to the internet and in-brain SMS, I mean, these will also connect to the network of AGIs around the world, and then anyone who wants to can jack into this sort of global mind matrix. And if you look at the advance of technology and what we use it for, I mean, we use these things for email, we use them for SMS, we use them for like Facebook Live video streaming. More than anything else, we use this technology to become closer and closer to other people and network together. So I would imagine once we have the in-brain chip, I mean, that there's going to be an awful lot of use of that to network people together into something that even goes beyond being an individual in the sense that we see it now. Now, where that leads, we really can't know. I mean, we may discover aspects of reality that we're just not imagining now. This is scary. Yeah, it's always been scary in human history, and this may be a scary leap, but it's hard to know, because if we were living in a cave and someone described modern reality to us, we would think this world was pretty scary. I mean, the difference between where we are now and where our primitive tribal ancestors were is awfully dramatic, and a primitive human plunged into this conference room would barely recognize all of us as humans. So I think going into radically new frontiers and changing our way of life and our way of thinking is what humanity has done since we stopped being glorified monkeys and apes, basically. So when Stephen Hawking says AI could end the human race, and Elon Musk is worried that AI may kill everyone, I mean, I guess if you look through human history, there have always been people extremely afraid of radical change, and many of the things they've feared have happened, right? I mean, many of the things that medieval people hold dear are not around anymore, and many of the things we hold dear may not be significant in the future. But humanity has always been evolving into new forms. So I don't want to see an AI just take all of our molecules and repurpose them into extra hard drive space for itself or something. So, I mean, that's what Eliezer Yudkowsky, who's a friend of mine who's talked about this a lot in the U.S., like to say that the AI does not love you, the AI does not hate you, but he can use your atoms for something else. Right? So, I mean, that's not the future I want to see. I can't assign that a probability 0, but nor do I see why that's an extremely likely outcome. So we can't rule out these negative outcomes, but I think that we can do things that sort of militate against these negative outcomes and make them, qualitatively less probable. So I together with my friend Julia Mossbridge in California, we're pursuing a project specifically oriented toward making an AI that will have unconditional love toward human beings. So, I mean, why not? I mean, there's military making killer AIs, and there's Google making AIs whose main purpose is to advertise stuff to people to convince them to buy stuff they don't need. So, I mean, why not have an AI whose purpose is just to love people and be nice to people? I mean, at least let's throw that there in the mix along with all the other AIs. And if you're going to have an AI that self-modifies, becomes smarter and smarter and smarter and smarter, wouldn't it be nice if that AI had core to its design and its motivational system and its values, the desire to love and help everybody. I mean, there's no mathematical guarantee that after it reaches IQ of 10 billion, it won't completely switch and start to hate everybody. But still, I mean, I would rather have a benevolent, loving AI become super intelligent than a killer military robot or an advertising engine or an AI hedge fund or something, right? So I think that's quite worthwhile, and it's similar to the reason I'm working on applying OpenCog to medical AI, to curing human diseases, and with some colleagues I'm working on elder care AI in China, an AI avatar that helps chronically ill old people. I mean, if we roll out AI in positive and benevolent applications, as AIs become smarter and smarter, the odds seem higher that the outcome will be good. It's nothing like a mathematical guarantee, but I think it's maybe the best we can do. AI should be developed and distributed in a way that works against global concentration of wealth and helps everyone. So I'm involved with a group creating a project called Singularity Net, which it's a blockchain-based sort of globally distributed marketplace for AIs. And the idea is that anyone can basically upload an AI or host an AI on their own server, wrap it in our interface, which is a set of smart contracts, and then anyone who wants AI services can access this global distributed network to get AI services. Now, this doesn't in itself feed starving children, but it does provide a global marketplace where a clever AI developer anywhere in the world can insert their AI into this global marketplace, and if the thing succeeds, it can reach customers from anywhere who want AI services, and a certain percentage of the profit generated in this network is then donated to benefit projects that use AI and other technologies to help the needy in the world. So I think there's a lot of things we can do to militate toward positive outcomes, like building AIs that love people and want to help people, and making sure that AI is developed and deployed in a more equitable way around the world. Now, these don't prove that AI won't use our atoms for something else, because we're going into a completely uncharted frontier where we don't know what's going to happen. But it seems like the best we can do is to make that seed a seed with as much positive disposition toward all sentient beings as we can, and then as that seed self-modifies and improves itself, we'll watch it and we'll learn as it grows.